Good afternoon, everybody, and thank you, Bripay, for giving us the opportunity to present our two innovative project on the concrete road. So the first project is innovative road coating. So I'm Duc Tung Dao, road engineer in the past, and now project manager for all R&D projects on the concrete road. So the first one is an original solution that we can use to improve the safety and durability of the concrete pavements. I'll show you the context rapidly, the concept of the innovative road coating, a focus on the durability of the innovative road coating under the accelerated pavement testing, so with the real traffic but accelerated way. And then I will show you the full-scale construction of this structure in the south of the France, and I finish with some conclusions and perspective on this idea. So rapidly, we already knew about the difficulties of the concrete pavements versus the asphalt, mostly on the riding comfort and safety. For both, the maintenance is a huge problematic. And we are so late for the versus compared to the asphalt developers, at least at the last 20, 30 years, when we talk about the EME1, EME2, GB5, or polymerized bitumen materials. So that's why our research center decided in 2015 to work on this new idea, how we can covers all the difficulties by being competitive to the asphalt developers. So this is our concept. By separating the structure by two layers with separate functions. The first one is the semi-pervious concrete, which is very thin, up to only 3 centimeters, that can be placed wet on wet or wet on dry on an eco concrete. And the eco concrete we can name like the ZPCP, CRCP, RCC, which use the low quality raw materials that don't need to meet the quality criteria like they use for the top layer or the wearing layers. Our laboratory studies carried out from 2015 to 2018, showing that by using this structure, we can have a safer structure, because it can help to avoid the aquaplaning phenomenon with the splash and spray waters. It's more comfortable because we talk about the top layer places by the vibrating table or vibrating script, so it's negative macro texture. It's a connected voice, so it's less noisy than the gap dense or the ordinary concrete. For sure, it's more durable because we use the polymerized cement to make our semi-pervious concrete. So in terms of mechanical strength, the top layer, so we talk about the semi-pervious concrete, can go up to 40 or 45 MPa in compressive strength and up to 12 or 14 in terms of flexure strength. It cost effective because we can have double optimization in terms of thickness and in terms of concrete formulation for both types of concrete. And for sure, last but not least, we have a cold placement with a huge choice in terms of color. It means that we can apply it for the highway, but for the interurban lengths, if we want to make the differentiation in terms of length. We carry out all laboratory tests, including the free throw resistance, noise absorption by the impedance tooth tip or something like this. So at the end, we conclude that it had to be checked by the accelerated pavement testing. So we use this kind of machine called FABAC, which was developed by public laboratory in France. Now it become FN University, Gustave FN University, used in the last decenny for the reinforced concrete pavement testing. So this machine composed of 4 sets of dual wheels. So each dual wheel will give a stress of 65 kilonewtons. So it's equivalent to the stress generated by the French standard equivalent as a load, with a load speed of 3.6 kilometers per hour. And we carry out the test from November 2016 to June 2017. So the monitoring program is classical with visual inspections, air temperature and pavement temperature survey, transverse profile measurements, mean texture depth measurements with skid resistance measurement by the skid resistance tester, so British pendulum, and dynamic friction tester by Wayne and Shoe test. And for sure, we core before the loading to check the bonding chain between layers. So some pictures about our slab construction. We saw exclusively two small joints, just filled by a polymer, just to create the weakest points in this slab. And then we run the APT test up to 5 million cycle loading. With this kind of structure, it means that around 21 years of traffic T1 in the French category, meaning 500 heavy lorry per day per length, or if we back calculate it by ASTO 93, it's around 16 to 24 years of highway traffic, meaning 1,500 to 2,500 heavy trucks. And then we carry out the monitoring program during this 5 million cycle loading. The first one is a visual inspection, so we didn't observe any rotting damage on the surface, even on the joint areas. With the transverse profile measurement, there is no difference between initial and then finish status. With the skid resistance tester and or dynamic friction tester, we saw the evolution of the friction coefficient. But at the end of 5 million loading cycles, the value was still acceptable. So it means that maybe after 20 years, there's no issue in terms of safety or in terms of routing. Still on this solution under heavy traffic. And then we move to the construction, full-scale construction investigation. So we launched it in 2017 in the south of France to test the possibility of production and then the placement of this solution. And here we did a small innovation by using a classical slip form, bringing an asphalt vibrating screed. The idea here was to test the placement of 2 layers at the same time. So you remember that once we do, if we want to do the 2-lip payment or 2-lip placement, we normally use 2 slip form. The second one is around maybe 30 or 40 meters after the first one. And here we need only 1 slip form machine. And why slip form machine? Because the bottom layer concrete was this ZPCP concrete. For sure, if we use the RCC, it can be an asphalt pavers. And in this case, have to use maybe 2 asphalt pavers. So small video about this. So bottom layer has 0 concrete. So here we deliver it directly the innovative coating inside because the size of the job site was so small. So the idea that the asphalt paver screed vibrate and compact the innovative coating directly on the top and by wet on wet mode of the S1 GPCP concrete. We brought this from our laboratory, but finally at the end of the day, it didn't make any efficiency, so we remove it later on. So as I said, it's a negative macro texture. So we extract it for the density control and for the bonding strength. It's for the pull-off test. And you can see how the voids were well connected by sending the air from the other side. So rapidly for some conclusions and perspective. So again, through this study and investigation, we can say that it can be used for durable and safe wiring costs for the rigid pavement under very high traffic. It can be competitive to the standard asphalt or ordinary concrete solutions. It is possible to place this concrete fresh on fresh or fresh on dry with the use of existing equipment like the slip form or asphalt paver, or we can easily modify the slip form if you want to do only one pass for the 2-layer placement. So up to now, unfortunately, we finished this study, this project in end of 2019, just before the COVID. So the project is now relaunched in Ecuador, Philippines, and Poland, for sure under our control. So I finished my presentation here. Thank you for your attention. Do you have any questions?